All right, so we got some examples here, and they're not telling us, hey, this is angle-angle similarity, or this is side-angle-side similarity, or that this is side-side-side similarity. We have to kind of make that decision on our own. All right, so right off the bat here, we have two triangles. We have this big one, X, Z, Y, that's easy to notice, and then we have another one that's X, W, V. Right off the bat, I notice I have at least one angle here. So I could be thinking, all right, side, angle, side. But we don't have any sides to go with it. So I might start thinking about, well, I need to concentrate on angle-angle similarity. But we don't have any information about this one here, so we can't prove that these two are congruent to each other. But what we do have is that this angle up here at the top is sharing on both triangles. Well, if they use the same angle, then they have to be congruent. So we have angle X in both triangles. We have angle 80. There's the two angles that we need. This angle here is going to have to be congruent. So this is a yes by angle-angle similarity. Now let's start off with a big triangle. X, Z, Y. Corresponding points. X, W, V. Once again, but remember, both triangles shared angle X. That was where our second angle was congruent, and then we knew that these two angles were 80. Okay? 6. I have sides. So I could be thinking, all right, well, you know what? This side here is 9, and this side here is 15. Okay? Well, this is going to be side, side, side. But we don't have the base of these two triangles. What we do have is that they share angle L, just like we shared angle X over here with these two triangles. So this is a side angle side similarity. Well, I jumped to that conclusion pretty fast. I'm supposed to prove that the sides are proportional, okay? So the big triangle is 9, the small triangle here is 6, so I'm gonna go 9 over 6. Over on this side, the big side here is 15, and the small triangle, this side is 10. Now, these are definitely not the same numbers. I need to simplify this down, okay? If I do it by 3 here, I would get 3 halves. If I simplify this by 5, I would get 3 halves. So I have a common ratio, and these are proportional to each other. So yes, side, angle, side. Now, naming it, let's start off on the big one. Let's just go JLN. JLN. Now, corresponding sides with this, J corresponds with K, L, M. All right, 7. Things get a little weird like this, and they like to kind of confuse us. But as we look at this, we have one triangle up here that has a side 3, 5, and 6. We have another one down here that is 6, 10, and 12. From E to F is 12. Okay, so as I have to decide here, what sides correspond with what? Well, as I look here, this one, the 3 is the smallest. Well, which one's the smallest on the big triangle below it? 6. Those are the corresponding sides. Okay, the biggest side here is the 6. The biggest side for this triangle is going to be E to F, which is 12. So those are the corresponding, leaving 5 and 10 to correspond with each other. Now that we understand which ones correspond with each other, we can set up our proportions. Let's go big over small. So 6 over 3, that's going to simplify to 2 over 1. 5 and 10, so that's big over small, 5 over 10, which is also 2 over 1. And then last, 12 over 6, which is 2 over 1. We have a common ratio between all 3 sides. So this is yes. We use 3 sides, side, 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 similarity. Now, naming this, make sure that we do this pretty good, careful here, because as I look at this, E here to D to G. I went small side to the medium side to the third side. So small sides here, F, E, H, E. So as I do this, EDG, the corresponding angles here would be FHE. Got to be very careful on how I name those. Okay, on example 8, as we look at these two triangles, we notice that there are some sides already listed, and that we do know that angle C is shared by both triangles. So maybe we're thinking side, angle, side. But there's one issue with that, and that's this X that's up here. We don't know what that X is right off the bat, so we can't prove side, angle, side similarity because we don't know what X is. We don't know, down here we know that this length is 7, but we don't know if that's going to be proportional up here with 3 and whatever the total is. So we can't do that. All right, what can we do? There's other clues on here that are going to really help us through here, and that's these arrowheads right here. Parallel lines, okay? Coach Lambert's going to break out some tricks here. Patty paper, love it. You can see through it, okay? As we look at this, we have parallel lines, and then we have a transversal. I'm going to just slide this right over here. And if we're looking at this, these two angles here are corresponding. And corresponding angles are always congruent. So if I go back to that, and I look right here, that tells us that E and this portion of D have got to be congruent. So that's another way, another method that I could show and that I can use, because parallel lines, I can reflect back to what we've done in the past to pull up and prove that two angles are congruent. So I did that there. I could also do that up here, parallel lines, and treat this as my transversal. And now I have another set of corresponding angles here and here. And that's where A and B are up here. So the patty paper really helps kind of show that out. So I also know 1, 2, 3, 1, 2, 3, 3 arc marks. So even though I went ahead and showed you guys that all three angles were corresponding and congruent to each other, that we only need to prove that, or to prove that these two are. This is yes, angle similarity. Now we know that they're similar triangles. Now we can go figure out what these missing parts are. All right. So as I look at this, I see there's two triangles here. You got the big triangle, and this side here is 7. 7's going to correspond with the 4. Then I have the top part here, which is x plus 3, and that's going to correspond with just the 3 part. And then we have the 8, which corresponds with the y. Now we're going to find our common ratio right here, big to small. We're going to use 7 over 4. We're going to use that as our ratio. It doesn't simplify, so that is it. And then the next part, let's do y first, 8 over y, big to small. Proportion, got to cross multiply. 7y equals, now 8 times 4 is 32. What's the last step that we need to do to solve this? Divide by 7, and y equals. Okay, and as we use the calculator, 32 divided by 7, notice that we get this big long decimal. That's okay. We're not going to write that. We're going to turn this back into a fraction. I want to show you all that calculator trick to turn in decimals back into fractions. Math, frac. Let's try to get that glare off there. Math, frac. Now it says answer, turn to fraction, enter, and we're just going to leave it as that. It's simplified, meaning that 32 over 7 never was going to simplify anyways. 32 over 7. And that's our answer there. Okay, the next part, we're going to solve for the x. Still use that common ratio of 7 over 4, and that's going to be proportional to x plus 3 over 3. Now we have to cross multiply, but when we do our 4, we have to distribute the 4. 4x plus 12 equals 21. Now we want to step through this, just use our algebra, isolate our 4x, subtract 12 from both sides. 4x, 21, subtract 12. Is 9. Then we divide by 4. And that's not going to break up either. We'll just leave our answer as that fraction 2, 9 over 4. So we kind of got a crazy example there in leaving our answers as fractions, but the process stays the same. Prove that the triangles are similar first, and then solve for your missing sides. But before you can solve, you have to make sure that your triangles are similar. Okay, the last two examples here. Are the two triangles similar? And if so, what is the common ratio? Well, we have our triangles ABC. Let's draw a picture so we have that A, B, C. And then now it's going to be 4, 5, and 7. 4, 5, and 7. Now I'm going to take real special notice on how I labeled everything. A, B, C. So this is going to be X, Y, Z. 4, 5, 7. I'm going to do 16, 20, and 28. Okay. Now, they don't give us any information about our angles, so we have to concentrate on side, side, side. Okay, 4 over 16. That would simplify to 1/4. 5 over 20. That would simplify to 1/4. Divide the top and the bottom by 5. 7 over 28. Divide the top and bottom both by 7, and we get 1/4. We have the exact same ratio. That is our common ratio of 1/4. So yes, these are a triangle. These are similar triangles by side, 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 and the common ratio is 1/4. Now as we look at 10, we'll set it up the exact same way. P, Q, R, S, T, U, and this is 3, 5, and 6, and this is 2.5, 2, and 3. And one thing I noticed is that 3, 5, and 6, I started small and I got bigger. Now here I went 2.5, and then I went smaller and got bigger. So I can already tell something's a little different here. But if I take my corresponding parts here, 3 over 2.5, 5 over 2, 6 over 3, do we get the same common ratio? Okay, I can cheat, I can use my calculator on this. 3 divided by 2.5, I'm gonna get that decimal, and I'm gonna turn that decimal back into a fraction by going math, frac, enter, enter, and I get 6 over 5. I'm gonna repeat that process here. 5 divided by 2, get my decimal, math, frac, enter, enter. I get 5 over 2, gets me right back to where I started. Then 6 divided by 3, math, frac, and I get 2 over 1. Are these the common, do they have a common ratio? No. These triangles are not similar. So in order for them to be similar, they had to have the same common ratio. Thanks, guys. Thanks for your time. Please make sure that you're working hard on this. I know I'm not going to be here today, but make sure that you're getting your job done, and just being efficient with your time that you have. Y'all have a great day, and appreciate y'all, and see y'all when I get back.